Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. Let's continue on the geometry treasure Incenter, Excenter in circle X circle property. So it's property 10. Circle OB, circle OC are X circles of triangle ABC. Circle I is an in circle of triangle ABC. EF are tangent points of circle I to line ACAB. OCE meets OBF on P. Prove that PI is perpendicular to BC. So this is point I, this is A, B, C. And we know that we want to find the circle OB and circle OC. So to find the circle OB, right? This is OB and this is OC. So we have OB here, we have OC here, and we want to find the foot as E and F. And then we know that OBF and OCE meets on this point, call it P. Right, this is not an accurate figure, but it's perfect because it won't distract us based on the figure. So let's rephrase this problem again. We have the triangle ABC, we have the in circle I, and we have the X circle OC and OB. We know that DEF are the tangent points of the triangle ABC to the in circle I, and we connect OBF, we connect OCE. OBF meets OCE on the point P. Now we want to prove that PI is perpendicular to BC. Because we already know that ID is perpendicular to BC. So basically we're trying to prove that PID are collinear. Right, so for this problem, I will need to use a very interesting way to show how to, like it's a pure new way to prove that 3 points are collinear. The first thing we notice about this problem is that we know AI is the angle bisector of angle BAC, right? AI is the angle bisector of angle BAC. And also we know that OCOB is the angle bisector of the X circle. Sorry, OCOB is the angle bisector of this X angle of the angle BAC. So we know that OCOB is the angle bisector of 8, right? Then we have the idea that AI is actually perpendicular to OCOB, right? Because this angle is half of this one, this is half of this one, and the summation would of all of these angles is 180 degree, so the half would be 90 degree. That means AI is perpendicular to OCOB. And also, AI is perpendicular to EF, right? Because AF equals to AE, and AI is angle bisector of angle BAC. So AI is perpendicular to EF as well. Then we know that EF is actually in parallel with OCOB. Right, EF is in parallel with OCOB. which means we get that triangle OCPOB is similar to triangle EPF. Right? That's what we can get so far. And back to the problem that we want to prove PID are collinear. So for this problem, it may be easy to think of that we can try to prove that angle PDF equals to angle IDF, right? Or angle PDB equals to angle PDC, right? Which is a little more difficult. So let's focus on if we want to prove that angle PDF equals to angle IDF. Then we realize one thing. Generally, this is a point that I want to make from this figure. If you still remember what we learned before in the previous two videos of we want to prove the perpendicular relation, we cannot just use half of the figure, right? We have to, for example, in the I think it's property 7. Yeah, in that one, we want to prove the perpendicular relation. So we have to use the Mealy's theorem twice. And in the property 8, we also use the Mealy's theorem twice. Which means in this case, if we want to prove that angle PDF equals to angle IDF, that means we're not really using the other half of the figure, which cannot be true. I mean, cannot be a good method or the correct path, right? It will be extremely difficult. Then think about that. We still want to use the angle PDF equals to angle IDF, right? We want to use it, but it's the same difficulty to prove that angle PDE equals to angle IDE. It will be very difficult, right? And that is not the correct way, because in that way, we're not really using the other half of the figure. To fully use them, we can think that if we can find that angle, we can prove the angle ratio, the angle IDE to angle IDF equals to angle PDE to angle PDF, right? Something like this. The angle ratio, because basically the angle ratio IDF to IDE defines a line ID, right? And if the angle ratio PDF to angle PDE equals to the angle ratio IDF to angle IDE, that means P is also on the line ID, which means PID are collinear. So the question is how can we prove sine angle PDF to sine angle PDE equals to sine angle IDF to sine angle IDE, right? And now look at the figure, the angle IDF. We know the angle IDF, right? Because the ID is perpendicular to BC, and we know that angle ID, we know IFBD are cyclic, right? So the angle IDF equals to angle IBF. That's half of the angle B. Similarly, the angle IDE is half of angle C, which means we want to prove that sine angle PDF to sine angle PDE equals to sine half of angle B to sine half of angle C. Right, that's our target. It means we want to find the relation of the sine angle PDF to sine angle PDE. What is angle PDF? This is angle PDF, and this is angle PDE. it would be very useful to put this sine ratio into the triangle PDF and PDE, right? Because they are sharing the PDE side. So we know that sine angle PDF to PF equals to sine angle PFD to PD, right? Sine angle PDF to PF equals to sine angle PFD to PD. That's a sine law. And also sine angle PDE to PE equals to sine angle PED to PD. Right, we know about these two equations, and we know that PD are equal, which means we get sine angle PDF divided, we can use this one divided by this one, then we get sine angle PDF to sine angle PDE, right? Because it's divided, so we have the PE to PF on the left side, so we move it on the right side of the equation, then it becomes to PF to PE, right? Times this one to this one, sine angle PFD to sine angle PED. What is PF? This is PF, and this is PE, right? We know that we already proved the triangle OCOBP is similar to triangle PF, triangle EPF, right? We proved that. So we know that PF to PE equals to OBP to OCE, right? PF to PE equals to PF to PE equals to OBP to OCP. Wait a second. Yeah. OCP, right? It equals to OBP to OCP because FE is in parallel with OBOC. Then we can get the conclusion that it also equals to, we can use PF plus OBP, right? It's OBF to this one, OCE, right? OBF to OCE. So this equation becomes OBF to OCE times sine angle PFD to sine angle PED. So what is OBF to OCE times this one? Let's just check OBF times sine angle PFD. Sine angle PFD is sine angle OBFD. And we know that FD is perpendicular to IB, right? Because BF equals to BD, and BI is angle bisector of angle BAC. So we know that FD is perpendicular to IB. So OBF times sine angle PFD equals to, so let's call this point as M. And similarly, let's call this point as N. It equals to OBM, right? OBM to, this one would be OCN, right? We use OCE times the sine angle PEN or PED. That equals to OCN. So now we have the, it's difficult to, I want to draw it like that. Right, that's an, and also we have something like this, right? OBM and OCN. Now we can connect MN. Think about M and N. M is actually the midpoint of FD, N is the midpoint of DE, so MN is in parallel with FE. And we already know that FE is in parallel with OCOB, so we know that MN is in parallel with OCOB, right? We have MN in parallel with OCOB, which means triangle OC, let's say that OBM and OCN meets on a point, let's call it Q, right? So then OCQ, let's call this point as Q. OCQOB is similar to triangle NQM, right? Now we have that triangle OCQOB is similar to triangle NQM. Back to here, the OBM to OCN, OBM to OCN equals to OBM to OCN now equals to OBQ to OCQ, right? And OBQ to OCQ can be rewritten as sine angle OBOCQ to sine angle OCOBQ, right? That's OBQ to OCQ equals to sine angle OBOCQ to sine angle OCOBQ. Now the question is, how can we prove? We already know this, the ratio of this one equals to the ratio of this one. Now it's equivalent to prove that sine angle OBOCQ to sine angle OCOBQ equals to sine half of angle B to sine half of angle C. Now let's look at angle OBOCQ or OBOCN. What's the angle of OBOCN? Think about that. N is a midpoint of DE. N is actually, CN is actually the angle bisector of angle BCA. And we know that OCC is also the angle bisector of angle BCA. That is saying OCNC are collinear, right? Similarly, we have BMOB are collinear. Okay, because OCNC are collinear, that means the angle COCOB can be easily calculated now, right? Let's do that. This relates to the property of the Excenter side. I know maybe you already forgot about these properties. Let's just repeat that again. It's actually about that the OCC is perpendicular to, let's call this OA, right? You can see that the angle BCOA equals to angle OBC, whatever here, right? And that's half of this angle. So we know that the angle OC is actually, the angle OC is actually 90 degrees, right? And similar for here. Then we know that BOB and COC meets on the point. We call it Q. This Q is actually the point I, right? It's actually the point I because this OBOC and sorry, this OBB and OCC intersection point is also center of the triangle OAOBOC, right? And it's also these lines, the OBB and the OCC, they are also the angle bisector of angle BCA and ABC. The intersection point would be the same point. That is saying the incenter I is actually the orthocenter of the triangle OBOAC, right? So this Q and I are the same points. And the question is, what is angle OBOCC? What is this angle? Then we want to calculate for this angle, the angle AOBC. Right? We want to calculate the angle AOBC. We know that this angle is 90 degree minus half of angle C. That makes this angle would be the angle, if we do the perpendicular line from OB to AC, right? We know that this angle will be equal to this angle, would be half of angle C, which means that this would be half of angle A. So the angle COBA equals to half of angle C plus half of angle A. Right? Then we know that the angle COBA plus angle COCOB equals to 90 degree, right? Because angle OCCOB is 90 degree. That means the angle COCOB equals to half of angle B, right? 90 degree minus this one, that's half of angle B. Similarly, we can get the angle BOBOC is half of angle C. Then, if you look at this one, get back to here, the angle COCOB, that is the angle QOCOB, right? Because Q is I, right? COCOB, that's Q or IOCOB, and equals to this one. So we directly prove that. Then we know that this is true. It means back to here, this is true, right? The angle ratio of PDF to PDE equals to this one, which means the angle ratio of the PDF to PDE equals to IDF to IDE. That is saying PID are collinear. Okay, so I think this is a pretty new method that I introduced here. I think it's the first time I use this way, but it's actually a very useful way. We will see in the future, especially for the problem like this, right? It kind of has a symmetrical on the, like according to the PID, this line, right? If we want to find the angle PDF, it's equal difficulty to find the angle PDE, right? And it will become very difficult if you just want to prove that angle PDE equals to angle IDE. But instead, we can prove the ratio, right? If we can prove that the ratio are the same, then we can directly say that the PID are collinear. This is an extremely useful method used in lots of difficult problems. I would strongly recommend to learn about this method. It's all have this one in your mind. Okay, that's today's video, and I hope you like this one. See you in next one. Thank you.